Alkaline metals. There's a difference. This is alkali, this is alkaline. You ever heard of alkaline batteries? Group 1, group 2. Group 2 that has 2 valence electrons. Group 3 through 12 have several, so we skip them. We won't do them for this class. If I give you one, I'll have to tell you what it is. Group 13, named for the first element in the group, the boron family, which has 3, not 13, has 3 valence electrons in the outermost shell. Not a total of 3, the outermost shell only has 3. 14 is nitrogen family. So everything acts like nitrogen. 15, I'm sorry, I'm off one. Number 4, 14 is carbon family. 15 is nitrogen family. It has 5. 16 is oxygen family. It has 6. 17 is the halogen. We don't call the fluorine family because they all are salt formers. The word halogen means salt. So they make salts like sodium chloride, table salt. Okay? And they're going to make salts. These are the halogens. And then 18 are the noble gases. And noble means they do not react. They think they're better than advanced. No, they don't have emotions. They don't really have personalities. But they do not react. So they're considered noble. Okay, so we should have got the definition. I can put it, maybe put it back. Let's see. I'll give you a minute or two. Finish copying. I'm going to put the pen right there. So that way we know not to do 3 through 12. Okay, I'll come back to it in a minute. So we're going to look at what valence electrons are and then a way to represent them through something called Lewis dot structures. Okay, this video you just have to watch. It's just a little cartoon. And the next one, we'll have to copy down a few things.
Hey guys, I wanted to try something a little different in class today. Oh, you didn't recognize it? It's me, Mr. L, science teacher. I want to try something new today. How about that? Something new. Have you ever heard of those things called Draw My Life? For instance, my pregnant wife and I one day went to the doctor's office. We went to see what was going to be a routine ultrasound. At least that's what we thought. The ultrasound tech said, oh, you guys aren't having one baby. You guys are having 2. You guys are having twins. It was at this point when I looked at my beautiful wife and she looked at the ultrasound tech and said, ha 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 ha, that's a nice joke. Nope, it's not a joke. At which point I thought to myself, oh man, I'm gonna have 2 kids, this is awesome. But then I started thinking, oh, I'm gonna have to get rid of my beautiful Scion TC. Get rid of the Scion TC for one of those minivans. Oh. So that was an example of Draw My Life. So what I want to do is kind of do something a little similar, but have it apply to what we're talking about in science. So I'm going to have it called Draw My Science. Now, it wouldn't be fitting unless the D is shaped like the Ducks logo. So what I want to do is first we need to have an answer or respond, but an anytime I point at this during the video, I want you to respond with an answer to any question I may have. So let's get started by reviewing a little bit. What I'm going to draw here is an atom. Now, you all know what an atom is. It consists of quite a few different things: protons, neutrons, and electrons. Now, protons are what type of charge? Actually answer this time. Good. Protons are positive. Then we have neutrons, which are neutral, and then electrons, which are negative. Now, how do we find this out? Well, let's go ahead and take an element block. For instance, beryllium. We know that the atomic number tells you the number of protons, but also tells you the number of electrons. That's right. So if we count them up, we have 4 protons and we have 4 electrons. But how do we find the number of neutrons? Do you remember? Well, you have to round off the atomic mass, so that rounds off to 9. You subtract it by the number of protons, and that'll give you 5 neutrons. So the next thing that we're going to talk about, the new thing that we're going to talk about today, are valence electrons. Now, I'm sure you're kind of wondering, well, we'll shrug shoulders. What's that? Well, if we compare valence electrons to, let's say, a pizza, there's pepperonis, but then there's also the crust. Now, no matter how big or small the pizza is, the crust is always on the outside. That's the same thing we're talking about with valence electrons. So if we talk about another atom, for instance, beryllium, which is the example we used earlier, we have 4 total electrons, but how many valence electrons do we have? That's right, 2, because 2 are on the very outside of it. Now, I know what you're thinking. Great, I have to draw out the atom every single time I want to find valence electrons. But if you get to a huge atom that has a lot of shells, then it gets to be very difficult. Well, there was a Russian scientist, hopefully you remember his name, that developed the periodic table. His name was Dmitry Mendeleev. And when he developed the periodic table, every element had its place. Without it being in its place, it wouldn't make sense. So there were many different reasons for him doing this, much like the pieces of a puzzle. Every piece of the puzzle has its place to make up the whole thing. If there's a piece missing, you would know. Same thing with the periodic table. He arranged it in that specific way. So when we're talking about the periodic table, it goes by groups. So everything in the first column has 1 valence electron. Everything in the second column has 2 valence electrons. We skip the transition metals. Then we go to group 13. You just cross out the 1 in front of it. So that one has 3. Then group 14 has 4. Group 15 has 5. And then group 16 has 6. Group 17 has 7. And group 18 has 8. So depending on what element what group the element is in, you can determine how many valence electrons is in that element.
Okay. So, Lewis dot structures, valence electrons. That's the way to represent how many valence electrons there are. And you can write them out or you can do a structure. It's, for what we're doing now, is very simplistic, but when you put it together with other elements, it becomes still easy, but it's just a way to show which electrons bond to which when you start trying to model the elements.
Howdy everyone, this is Mr. Kazi here with another chemistry lesson, and today we're going to talk about valence electrons and Lewis dot symbols. In this lesson, we will talk about valence electrons and Lewis dot symbols. You will need a periodic table, unless you've memorized it. And remember, this is your #1 tool, so always have a periodic table available. And you must know
Well, apparently it's not wanting to play. Let me do a refresh. Hang on a minute.
symbols. In this lesson, we will talk about valence electrons and Lewis dot symbols. You will need a periodic table unless you've memorized it. And remember, this is your #1 tool, so always have a periodic table available. And you must know electron configuration, orbital notation, and the atomic models. Valence electrons. Now, the valence electrons are the electrons in the highest energy levels. And usually, this is an S and P orbital. And so when you look across at your different rows, and you look at your elements, the valence electrons are those electrons in the highest energy level at that time, and that's usually the S's and the P's, and you have somewhere between 1 and 8 valence electrons. Valence electrons, S and P's, and there look at the red, that shows us what we're looking at, and S plus the P's equals valence electrons. An example of this would be fluorine has 9 electrons. So 1s2, 2s2, and 2p5.
We'll go over
The
that
second energy
tomorrow.
level is the highest energy level, and 2 plus 5 is 7. So we have 7 valence electrons. Another example, how about potassium? It has 19 electrons, but if you find potassium on your periodic table, you'll notice that there is only one
Find
electron
potassium,
in the
symbol
highest
K.
energy level, and it's a 4s1.
What group is it in?
So 1 plus is 0, there are no P's, and we have 1 valence electron.
Okay, we'll finish that. We're not done, but we'll finish that up tomorrow because that goes into some electron configuration. Right now we're just talking about just the group number of valence electron. So on the screen, on the board, I have 6 practice problems. Okay, I'll give you a few minutes to copy this down. You don't have to do them. It's very simple, but you don't have to do them. You can if you want to. Check yourself. But copy down the question. How many valence electrons would each element have? And then I've got 6 of them. Lithium is 1, carbon is 2, 3 is bromine, 4 is oxygen, 5 is calcium, and 6 is argon. I've got group number / valence electron. Okay, we're going to look at, all you got to do is tell me what group it's in and what the valence electron is in. Okay, so I'm going to pause this at this time, let you have a minute to copy, or a few minutes to copy, and then I'll unpause it and we'll check it. So this time I'll pause it. I've unpaused it at this time, I hope. Everybody's got it copied. So let's look. Lithium. Lithium is in. Find that lithium. You're going to say, well, I don't know what lithium is. You have to look at the symbol. The symbol is Li. It's not L. There's no other L. Li. And I'll go over why some of them have 2 letters and some of them don't at a later time. So lithium, the symbol is Li. It's in group 1. So it has 1 valence electron. That's all we're doing. Lewis dot structures and electron configuration we'll do later this week. Carbon, symbol C, is in group 14. So it has 4 valence electrons. Bromine is Br, not B. B is boron. Bromine, Br. Group 17, so it has 7. Wow, that's really hard, right? Okay, now, find oxygen on the periodic table. Oxygen is in what group? Somebody? 16. Hopefully you said 16. So anything in 16 has 6 valence electrons. Calcium is in what group? Hopefully somebody said 2. So it has 2 valence electrons. And argon is in what group? It's in group 18, right? So it has 8. Remember, the group 18 has 2 rules. They're noble, so they can have 8 valence electrons, or their outermost shell is full. Now that concludes what we're going to go over today. If we got a few minutes, then I want you to study. I want you to look over stuff. Be on your phones. Don't get up. If not, then we'll finish up tomorrow. We'll go over electron configuration tomorrow. Okay, so that concludes.